Welcome to this Udemy course on 5G and 5G Advanced for absolute beginners. My earlier 5G for absolute beginners course has been available on Udemy since 2020. Since then, 5G has continued to evolve, and the latest major stage of that evolution is known as 5G Advanced, or sometimes simply 5GA. In this course, we will explain 5G and 5G Advanced in the simplest way possible. The aim is not to turn you into a radio engineer or standards expert. The aim is to help you understand the big picture, the key terminology, and why 5G Advanced matters. We will start with the basics, then gradually build up to the newer 5G Advanced topics. Before we go further, here is a short legal disclaimer. This course is intended for education and general understanding. The telecoms industry changes quickly, and technologies, standards, deployment plans, and commercial strategies can evolve over time. The material in this course is based on standards, industry knowledge, and publicly available information, but it should not be treated as professional financial or investment advice. Where anything is important for business, technical, or financial decisions, please verify it from official sources and consult relevant experts. You can read the full disclaimer in the downloaded slides. My name is Zahid Ghadiali and I am the Principal Analyst and Consultant at 3G4G. I have been working in mobile and wireless technologies for more than 25 years, from the early days of 3G through to 4G, 5G, 5G Advanced and emerging 6G topics. Over the years, I have worked as an engineer, analyst, consultant, trainer and technical marketeer. My work covers areas such as mobile standards, telecoms infrastructure, spectrum, private networks, IoT, satellite connectivity, Open RAN, energy efficiency, and future network technologies. I am also the founder of the 3G4G blog and training platform, where I regularly publish technical posts and explainers for the telecoms community. My passion is to explain complex technologies in simple terms, and that is exactly what I will try to do in this course. 3G4G is a boutique mobile telecoms technology, strategy, analysis, and consulting firm. We work with selected clients across the telecoms ecosystem, helping them understand technologies, market trends, standards, use cases, and future opportunities. Our work includes technology strategy, market analysis, competitive intelligence, product and solution marketing, technical marketing, expert reports, and training. On the technology side, we cover areas such as 5G, 5G Advanced, beyond 5G, 6G, 4G, Wi-Fi, private networks, public safety, LTE and 5G, IoT, M2M spectrum, and emerging telecoms market. The main idea behind 3G/4G is to bridge the gap between deep technical standards and practical understanding. We want to make mobile technologies easier to understand and easier to apply in the real world. Before we get into the main technical content, I also want to highlight some of the 3G/4G channels. The 3G/4G blog has been running for many years and covers mobile and wireless technologies, including 3GPP standards, 4G, 5G, 5G Advanced, 6G, Open RAN, private networks, spectrum, satellite connectivity, and many related topics. We also have a 3G/4G, 5G YouTube channel where we publish explainers, technical updates, training style videos, and summaries of the important telecoms developments. In addition, we run several focused blogs and training sites including free 5G training, free 6G training, telecoms infrastructure, operator watch, connectivity technology, and private networks technology. This Udemy course is part of that wider learning ecosystem. The course gives you a structured, beginner-friendly introduction, and the blogs and YouTube channel allow you to explore specific topics in more detail later. This course is divided into 5 short parts. In part 1, which is this lecture, we start with the journey from 1G to 5G. We will look at why mobile networks keep evolving and why 5G was designed for more than just faster phones. In part 2, we will look at how 5G works in the real world. We will introduce standards, 5G radio, the 5G core, standalone and non-standalone 5G, and why 5G performance can vary so much. In part 3, we will answer the main question: what is 5G Advanced? We will explain why it is not 6G, why Release 18 is important, and how Release 19 continues the 5G Advanced journey. In part 4, we will look at key 5G Advanced features and use cases, including AI, energy efficiency, red cap positioning, XR, private networks, and enterprise applications. Finally, in part 5, we will look at satellites, non-terrestrial networks, the road to 6G, and the overall course summary. The goal is to give you the big picture and enough confidence to understand what 5G and 5G Advanced are really about. Now that we have introduced the course, let us begin with the evolution of mobile technology. Before we talk about 5G Advanced, we need to understand what 5G was designed to do. Many people think of 5G simply as faster mobile internet, but the real story is much bigger. Mobile networks have evolved from basic voice calls to connecting people, machines, industries, and critical services. Today, mobile networks support smartphones, video, apps, connected vehicles, factories, sensors, public safety systems, and much more. In this lecture, we will look at what each generation of mobile technology brought to the world and why 5G became such an important step. Let us start with a basic question. What does the G in 1G, 2G, 3G, 4G and 5G actually mean? The answer is simple. G stands for generation. Each generation of mobile technology represents a major step forward. It is not just a new marketing name. A new generation normally brings new technologies, new network capabilities, new types of devices, and new services. For example, when the 3G standards were available, mobile phones started becoming internet devices. When the 4G standards were available, mobile broadband became fast and reliable enough for apps, maps, social media, and video streaming. User expectations also change with each generation. In the early days, people were happy if they could make a mobile phone call. Today, people expect video calls, cloud apps, streaming, messaging, navigation, and reliable internet access almost everywhere. So when we say generation, we are talking about a major change in what mobile networks can do. This slide shows the journey from 1G to 5G. 1G was mainly about mobile voice. It allowed people to make phone calls without being connected to a fixed telephone line. 2G introduced digital mobile communication. It improved voice services and made SMS messaging popular. 3G brought mobile internet. It was not always fast by today's standards, but it introduced the idea that the mobile phone could be used for data, email, and web access. 4G made mobile broadband practical. This is when smartphones, apps, video streaming, maps, social media, and many other services became part of everyday life. Then came 5G, which was designed to go beyond smartphones. It was created for faster broadband, lower latency, more connected devices, and new business and industrial applications. The important point is this: each generation solved a different problem. 5G was not created only because people wanted faster phones. It was created because the world needed a more capable connectivity platform. Let us look briefly at the first two generations. 1G was the analog mobile voice generation. These early mobile networks were designed mainly for making calls. The devices were large, expensive, and limited compared to today's phones, but they were revolutionary at the time. For the first time, people could make calls while moving around without being tied to a fixed phone. Then came 2G, which made mobile communication digital. This brought several improvements, including better voice quality, better security, and more efficient use of spectrum. 2G also introduced one of the most successful mobile services ever, SMS or text messaging. For many people, 2G was the generation where mobile phones became personal communication devices. You could call, you could text, and mobile phones started becoming much more common. So 1G and 2G were mainly about communication, voice first, then voice and text. The next big shift came with 3G and 4G. 3G introduced mobile data and internet access. It allowed people to check email, browse websites, and use early mobile apps. The experience was often slow compared with today, but it changed how people thought about their mobile phones. A mobile phone was no longer only for calls and texts. It was becoming an internet device. Then 4G made mobile broadband much more practical. With 4G, people could stream video, use social media, rely on maps, use cloud services, make video calls, and run many different apps. This was also the era where smartphones became central to daily life. 4G changed expectations. People no longer wanted mobile internet only occasionally. They expected fast and reliable access all the time. This is why 4G was such an important step. It made the mobile network a platform for digital economy. So, if 4G was already so successful, why was 5G needed? There were several reasons. First, there were more users. More people around the world were using mobile broadband every day. Second, there was more data. Video, apps, cloud services, and social media created huge demand for mobile capacity. Third, there were more devices. It was no longer just phones. We started seeing wearables, sensors, connected cameras, vehicles, and many other connected things. Fourth, applications became more demanding. Some applications needed faster response times, better reliability, or more consistent performance. And finally, businesses and industries wanted to use mobile networks for much more than consumer connectivity. Factories, ports, mines, utilities, transport networks, and public safety organizations all started looking at wireless connectivity in new ways. So 5G was needed because networks were no longer serving only people with phones. They also needed to support machines, industries, and critical services. This is one of the most important messages in the course. 5G is more than faster downloads. Yes, faster mobile broadband is an important part of 5G. For many consumers, this is the most visible improvement. Faster downloads, better streaming, and improved mobile broadband are all part of the 5G story. But 5G was also designed to support lower latency. Latency means the delay between sending information and getting a response. Lower latency is important for applications that need a fast reaction. 5G also aims to support better reliability, especially for business and industrial applications, where connectivity may be part of an operational process. Another major goal is to connect more devices. This is important for IoT, sensors, smart cities, utilities, and industrial monitoring. And finally, 5G was designed to support industry and enterprise services. This includes private networks, smart factories, connected transport, ports, mines, public safety, and many other areas. So the simple message is 5G is not just about speed. It is about creating a more flexible and capable connectivity platform. The original 5G vision is often explained using three broad categories. The first is EMBB, which stands for Enhanced Mobile Broadband. This is the part of 5G that most people understand first. It means faster and better mobile broadband, including improved video, apps, and internet access. The second is URLLC, which stands for Ultra Reliable Low Latency Communications. This is about reliable, time-critical communication. Examples could include industrial automation, remote control systems, or applications where delays and failures must be minimized. The third is MMTC, which stands for Massive Machine Type Communications. This is about connecting very large numbers of devices such as sensors, meters, and machines. Do not worry if the acronyms sound complicated. The ideas are simple. 5G was designed for three broad needs: better broadband, more reliable, low latency communication, and massive numbers of connected devices. Not every use case needs all three. For example, streaming video mainly needs broadband. A sensor network may need low power and large scale connectivity. A factory automation system may need reliability and low latency. Different use cases need different types of 5G. Another key difference with 5G is that it was designed for both consumers and industries. For consumers, 5G supports smartphones, video streaming, video calling, gaming, fixed wireless access, etc. Fixed wireless access means using mobile network technology to provide broadband to homes or businesses instead of using fiber or copper in the final connection. But 5G is also important for industries. Factories may use 5G for machines, robots, sensors, and quality inspection. Ports may use it for cranes, cameras, vehicles, and logistics. Mines may use it for automation, safety, and remote operations. Utilities may use it for monitoring and control. Transport systems may use it for rail, roads, and connected vehicles. Public safety organizations may use it for resilient communications and situational awareness. This is why 5G is often described as a platform for digital transformation. It is still important for phones, but it is no longer only about phones. Let us quickly summarize what we have learned in this first lecture. First, the G in 1G, 2G, 3G, 4G and 5G means generation. Second, each generation solved a new problem. 1G brought mobile voice, 2G added digital voice and SMS, 3G brought mobile internet, 4G made mobile broadband and apps mainstream. Third, 5G was designed for more than smartphones. It was created to support people, devices, machines, industries, and critical services. Fourth, 5G supports three broad ideas: better broadband, lower latency, and massive IoT. And finally, 5G Advanced builds on this foundation. It does not come out of nowhere. It is the next stage in the evolution of 5G. In the next lecture, we will look at how 5G works in the real world. We will talk about standards, 5G radio, 5G core, standalone and non-standalone 5G, and why the 5G experience can be very different from place to place. Here are some useful references and links for further study. This is an absolute beginner's course, so we are only covering the high-level story in a simple way. But if you want to understand 5G in more depth, these links are good starting points. You do not need to read all of them immediately. My suggestion is to come back to them after completing this lecture, especially if any of the topics caught your interest. The important thing is to keep learning step by step. Mobile technology can look complicated at first, but once you understand the big picture, the details become much easier to follow. Congratulations on completing the first lecture. You have now seen how mobile networks evolved from 1G to 5G and why 5G was designed for more than just faster downloads. Please complete the quiz for this lecture and then you will be ready to move on to the next part of the course. In the next lecture, we will look at how 5G works in the real world. We will discuss standards, 5G radio, the 5G core, standalone and non-standalone 5G, spectrum, and why 5G performance can vary so much. You can also explore the 3G 4G website, blogs, YouTube channel, and training sites at your leisure. Thank you, and I will see you in the next lecture.